Hi, my name is Dahlia Vitarsi and I'm going to be talking about light-dependent reactions and light-independent reactions. First, we're going to talk about light-dependent reactions. We're going to start with light hitting photosystem 2, and it's going to make that electron jump straight up, and it's going to bounce off into the plastocation, which is also known as the H plus pump. From then, it's going to transfer to the plastocyanide, which is also a mobile electron carrier, and it's going to take it to the ferredoxin. Ferredoxin is the last electron acceptor, and it's going to take it to the NAD plus reductase. So in there, we're going to take that electron, and it's going to help NADP transform into NADPH. So continuing on, we're going to go back to the plastocation, also known as the H plus pump. From the H plus pump, we're going to have a high concentration in the lumen and a very low concentration in the stroma. So whenever the photosystem 2 loses an electron, to replace it, it's going to break apart the very stable water molecule, and that H ion is going to transfer over along with the H plus pump ions, and it's going to go up the ATP synthase, and it's going to help ADP with phosphate to transform into ATP. So in the light reaction, we have NADPH and ATP as our final products, along with oxygen, which is also known as the electron donor in the reaction, and is also the final acceptor in respiration. So continuing on, we're going to be talking about the light-independent reaction. Starting with the light-independent reaction, you're going to start off with sugar. And with sugar, you're going to get the CO2. With CO2, you're going to start with carbon fixation, which is caused by rubisco. Rubisco is pretty much going to suck up all the CO2 and transform it from inorganic to organic. So it's going to do that in large quantities, and with those large quantities comes toxic phosphoglycate, which is very toxic to this, but you're getting something very positive out of it. They can transform it into glycine, so it's not so toxic. And continuing on, we have a 6-carbon chain, and we're going to break that chain because it's very unstable. To make it stable, we're going to turn it into 3-phosphoglycerate, and that is very stable. There's going to be 2 of those. Continuing on, we're going to go on into reduction, and we're going to transform that into G3P, which is known as the ultimate product, and it can pretty much be any carbohydrate that it needs it to be. But there's 6 of them. Only 1 of them can leave the cycle. The rest of the 5 have to go on into the regeneration of the carbon dioxide acceptor. So it has to continue on into the cycle, and this cycle takes place about 6 times to complete 1 full cycle. And that is all. Thank you.